In this morsel, we're going to cover some of the basic network protocol concepts that you need to be aware of in this competition. The first is HTTP. That stands for Hypertext Transport Protocol. This is essentially any web traffic. Sometimes, and this is actually very important, you'll notice an S at the end, and that means that the connection is a secure connection. The mechanisms behind how this is secured is beyond the scope of this chapter, but it's important for you to understand the difference between a standard HTTP connection and one that is secure, which is denoted by the S, HTTPS. The next two we will go into a little more detail. The first is UDP, standing for User Datagram Protocol, and then TCP/IP, which is the Transmission Control Protocol and Internet Protocol. And this is actually a suite of protocols used together, with TCP and IP simply being the two main protocols in the suite. Now, for any of you that might already be a bit familiar with computer networking, in particular, you've fiddled around with a firewall, you might not care whether it's UDP or TCP, and when you have to open up a port, you just open up both UDP and TCP in your firewall. Well, in the case of your system security, you want to manage your firewall rules very carefully. If you were to allow both UDP and TCP, it's akin to poking a whole bunch of holes in your big suit of armor. You don't need to make more weak spots if you don't absolutely have to, and that's the case with the firewall. If you don't need to open the UDP port, you don't open the UDP port. As I've said already, UDP is one of the two protocols that you will need to be familiar with when working on your HPC systems. UDP is a connectionless protocol. It's used for loss-tolerating connections. The image on the right shows this in action. The sender doesn't really care if what it's sending out is not being properly received on the other end. If it receives a request from the receiver, it just fires off all of its responses. And I'll explain shortly when or why that would be a nice feature. It's important to know that UDP is a lightweight protocol, and it's this lack of waiting for a confirmation of a receipt before it sends more packets is why UDP is typically a low latency protocol. TCP/IP, on the other hand, is an error checking protocol. What this means is it waits for acknowledgement of its packets and then retransmits them if there's been some error. Because it is a connection-oriented protocol suite, there's a greater focus on integrity and security. This also means it's a more heavyweight protocol, and there is an inherent latency associated with TCP/IP. As an aside, I'm actually a little disappointed that we aren't able to go into more detail about TCP/IP because there's actually some really fascinating developments like Google's TCP fast open optimizations and congestion control mechanisms like cubic TCP. And not to be too bitter about it, and I know that all of you are chomping at the bit to know this stuff, I'm going to pause the next slide for just a few seconds so you can admire the simplified TCP state diagram and we can all scratch that itch. Putting the pieces together, if you have a web server that wants to send an HTML file to a client, it's going to use the Hypertext Transfer Protocol to do this. The HTTP program layer, which is layer 7, is going to ask the TCP layer to set up the connection and then to send the file. The TCP stack divides the file into its data packets and then numbers them and forwards them individually to the IP layer for delivery. Although each packet in the transmission has the same source and destination IP address, packets may be sent along multiple different routes. The TCP program layer in the client computer waits until all the packets have arrived and then it acknowledges those that it's received and asks for retransmission of any that it does not, because that is how TCP handles transmissions, and based on any missing packet numbers, those are resent. The TCP layer then assembles the packets into a big file and delivers the file to the receiving application. And there you have it in a nutshell. Right, I almost forgot. Earlier I mentioned to you that UDP was great for loss-tolerating connections. But you were all dying to know, when do we want a loss-tolerating connection? Well, interestingly, that is applicable for an HPC system. But a more generic reason for wanting a loss-tolerating connection is anything that is time-sensitive application, like voice over IP, streaming video, or even gaming. And because UDP has a lower latency. And why does it have a lower latency, I hear you ask? Because it doesn't have to worry about reordering packets or getting missing data retransmitted. And that's why you often perceive layers of resolution in a streaming video. You get the really blocky resolution, but over time, as you buffer more, the picture quality improves. And if there's a lot of loss in the connection, the picture quality will get worse, but you'll still see the video, but just at a lower resolution. and generally speaking, TCP is typically associated with a unicast type of operation, whereas UDP can be unicast, multicast, or even broadcast. And on the right are some of the services that you actually might encounter in your HPC environment that are loss tolerating connections, and they would use UDP ports in your firewall.